Algebra 1, Lesson 59, we are solving systems of linear equations by substitution. So instead of solving them by graphing, we are going to solve them algebraically. And we have 4 steps that we want to do. Number 1 is isolate. We want to isolate one of the terms in one equation. It doesn't have to actually be isolated in both equations, just one will work. And number 2, we're going to substitute that information in for the x or the y in the second equation. Solve for both x and y, and then check the solution by plugging it back into the original equations. So first we need to isolate. Number 1 is isolate, and we actually do already have y isolated in one of the equations. It's actually isolated in both, but we didn't have to have it that way. Number 2, we're going to substitute, and in here we say that y is equal to 2x minus 5. Y is equal to that, so we are going to place that information in where we see y in the second equation. And we get that 2x minus 5, sorry about that, let me just try that again. Okay, we're going to say 2x minus 5 is equal to 5x plus 7. So that we can now solve for x. And in this case, I'm going to subtract 2x on each side. And I get negative 5 is equal to 3x plus 7. Now I'm going to subtract 7 and get 3x is equal to negative 12. So I divide by 3 and see that x is equal to negative 4. Now right now I have half of the information I need. I know that x is negative 4, but what is y in my coordinate point? So I plug in negative 4 into either of the equations. So let's say I plug it into the first one and see that y is equal to 2 times negative 4 minus 5. So we say, oh, well, y is equal to negative 8 minus 5, so y is negative 13. Now, we know that that works for the first equation because that's where we got that information from. But let's plug it into the second equation to make sure that that coordinate point is our solution. So we say negative 13 is equal to 5 times negative 4 plus 7. And we get negative 13 is equal to negative 20 plus 7. So yes, this is our solution. Now our solution must be put into a coordinate point. We are not allowed to have just x equals negative 4 and y equals negative 13. I must have it as a coordinate point. Let's try another one. Solve by substitution. So we have our y isolated. So I'm going to plug this information in right here. And we get 2x minus 3 is equal to x plus 2. And I'm going to solve by subtracting x from each side. So I get x minus 3 is equal to 2. Add 3. And we see that x is 5. So I know part of my solution is 5 comma something. And I'm going to plug that x right into the second equation maybe. Y equals 5 plus 2. And so we see that y is 7. Now let's check to make sure that that works for the second equation. And we say 7 is equal to 2 times 5 minus 3. So is y equal to 10 minus 3? It definitely is. So this is our solution. Shown, remember, as a coordinate point. All right, now what happens if we don't have number 1 if we don't have our variable isolated? Well, we need to. And we look at each of these equations and say, which one will help me isolate one of the variables the easiest? And when I look at the first one, I see that x is the easiest to find in the second equation. Sorry about that. So we need to use that second equation and solve for x. So in that case, I'm going to subtract 4y and get that x is equal to 13 minus 4y. Now I can use that information into the first equation where I see x. So I'm going to plug that information in right for x and say 2 times, well, x is 13 minus 4y. And we have that plus 3y is equal to 6. Now I can distribute out and get 26 minus 8y plus 3y is equal to 6. And I can combine like terms to get 26 minus 5y is equal to 6. And subtract 26 from each side, so I get 5y is equal to negative 20. Divide by negative 5, and we see that y is equal to 4. So I have the second half of what I need. We see that y is 4, but what is x? All right, well, let's see if I can get myself a little bit more space here. Okay, let's see. Well, when we do this, I'll just show you when we have it all solved out. We see that y is 4, and then we're going to plug that into one of our equations. In this case, we're going to use the x plus 4y equals 13. So I plug in 4 for y and see that x plus 16 equals 13, so x is negative 3. So our point is negative 3 comma 4. And we know it works for that second equation, but let's check the other one. So 2 times negative 3 plus 3 times 4, does that equal 6? Well, I get negative 6 plus 12 equals 6. So yes, this does work, and that is our solution. Okay. Which method is using correct substitution? So with A, what we're seeing is they solved for y on each side, solved for y by subtracting 2x, and then they're using this information and plugging it in right there for y. So we have negative x plus negative 2 plus 4 is equal to 1. That looks like correct substitution for me. Okay, next one. It looks like they took this equation here and solved for y by adding x to each side, so that we get y is equal to x plus 1. And then they plugged in x plus 1 for y here, so that we had 2x plus x plus 1 equals 4. So that works. And then the third one. What they did, it looks like they wanted to solve for they wanted to solve for x, so they subtracted y from each side and got negative x is equal to negative y plus 1. And then they plugged that in for x over here, which it looks like they didn't plug it in correctly, because what they should have done, oh boy, I don't even know what they did. Oh, I see. They multiplied each of those sides by a positive 1, a negative 1, so they got positive x alone times equals a y minus 1. That works. So then I can take this y minus 1 and plug it in for y in my original equation, or x in my original equation, so that I get 2 times y minus 1 plus y equals 4. So all of these methods are actually correct, just different ways to do it. All right, let's try a couple more. Solve by substitution. So this one actually has x isolated already, so I'm going to take this information and plug it in for x to get 12 times 2y plus 11 minus 6y is equal to 12. So I get negative 24y when I expand, plus 12 times 11 is 100, and let's see, 132 minus 6y is equal to 12. So I can combine like terms here and get a negative 30y plus 132 is equal to 12. And I subtract 132 from each side. When I do that, I get negative 30y is equal to negative 120. So that when I divide by negative 30 on each side, I get y is equal to positive 4. So that's half of my solution. Y is positive 4. So I'm going to plug that back in for x. Y is equal to 4, so I do negative 2 times 4 plus 11, so that I get x is equal to negative 8 plus 11, or x is equal to 3. And I check my other one. I say, all right, is 12 times 3 minus 6 times 4 equal to 12? Well, I get 36 minus 24, and yes, that does equal 12. Okay? Let's see. Now this is one that you can try out on your own. Remember, isolate, substitute, solve, and check. Okay, and here's another one as well. Okay, let's try another one. So a school play charged adults $8 and students $5. There were 75 people who attended the play. The box office collected $444. How many adults and how many students were at the play? Well, we actually need to write two equations here. Number one will add together the number of students and adults to get a total of 75 people. And the other will take those number of students and adults and multiply by how much it costs for each of those to get a total of $444. So in the case of the people, I'm going to say adults will represent as X and students as Y. So the number of students plus the number of adults is going to be 75. Now, each student or each adult, X, is going to be $8. So 8 times the number of adults plus 5 times the number of students will give me that $444. And now I have my two equations that I can isolate and substitute. So I'll use the first equation here and say, well, X is equal to 75 minus Y. So I'm going to plug that in where I see X in the second equation to get 8 times 75 minus Y plus 5Y is equal to 444. So 8 times 75, let me see what that gives me. Gives me 600 minus 8Y plus 5Y is equal to 444. So I combine like terms and get 600 minus 3Y is equal to 444. Then I'll subtract 600 and get negative 3Y is equal to negative 156. So I'll divide by negative 3 on each side and see that Y, the number of students, is 52. We had 52 students there. And then I'm going to plug that into my original equation, or the X is equal to 75 minus Y, so 52. So we see that the number of adults is 23. And if we plug that into my second equation and do 8 times X, 23, plus 5 times 52, we do end up getting 444. Okay, so this is an example of how we can create a system of equations in order to solve a problem. Here's another example that's very, very similar. Okay, and a second one as well. Well, I hope this helps with your homework and for studying.